Okay, welcome back to the classroom. My name is Mr. Wong. We are going to go through the 2006 HSC physics paper. This is question 18 worth 3 marks. This is going to cover module 5, inquiry question 3. We have an object that is stationary in space and located at a distance from the center of a certain planet. It is found that we use 1.0 megajoules of work to move the object from a stationary point, to move it from a stationary point 20,000 kilometers from the center of the planet. So go from 10,000 kilometers to 20,000 kilometers. Calculate how much more work needs to be done to move the object from a stationary point 8,000 kilometers away from the center of the Earth. Okay, so there's two methods to work this out. We know that work done is equal to the change in gravitational potential. So that could be UG final minus UG initial of this. Okay, so that's what we have. If we look at the difference of 10,000 kilometers to 20,000 kilometers, what we're going to try and do is figure out from the formula what is the value of m or gmm over r. So we know what r is, we know what g is, but we don't know what m and m means. Okay, so we'll just try to find this top bit here, and then we can do the same calculation again, but this time for the 80,000 kilometers. Okay. So if we have a look, the amount of energy used is this value here. We have GM, so I'll just write it down in different color, how we try and propose that. Well, actually, we'll just leave it as it is. So it'll be negative GMM over the final position, which is 20,000 kilometers. Convert that into meters. That's what we get. Okay. This bit it says subtract, but we can also see that gravitational potential as a value is also a negative value. So it actually ends up becoming an addition. So GMM over 10,000 kilometers, or 10,000 10 to the power 3 meters. Okay, next thing is obviously getting the equation, solving for our fractions so that they have the same common denominator. So what we can do is we can times this, or we can increase this fraction by 2. Okay. So we're going to make this component here go up by 2. So this is going to become, or at least on this side, it's going to become GMM 2 over 20,000 meters, like so. Okay, so our equation, if we just go back to the other color, becomes something along the lines of 1 times 10 negative GMM over 20,000 meters plus 2 GM 20,000 10 to the power 3 meters. Okay, you could end up writing the equation like this. So get rid of 20,000. And you could actually end up writing our equation like so, and 20,000 like so at the bottom here. Obviously, we haven't solved for this side of our equation yet, we want to find the relationship of just GM. So what we can do is we times both sides by the 20,000 meters, and we get 1 times 6 times 20,000 meters equals to negative GMM plus 2GMM, gives us a value of GMN, which is equal to, let's just plug it into the calculator, 2 times 10 to the power of 13. Now, there's no units here because, how to put it, GMM is not an actual unit of measurement, it's just a couple of constants added together. So that's what we have. Now we can actually work on how much work done is needed to move it to 80,000 meters. So it says how much more work needs to be done. So now we're looking at the scenario of we started at 20,000 and we now want to move it to 80,000. So we go from 20,000 kilometers to 80,000 kilometers. How much work was used in that process? Okay, you could also just simply use the 10,000 and do that, but we'll do it this way. So the work done is equal to negative GMM over the 80,000 plus GMM over the 20,000. Okay, this time we don't have to try and solve for, or this time we actually can just substitute GMM. So it's negative 2 times 10 to the power of 10 to the 13, 80,000 times 10 to the power of 3, plus the following as well. So let's find out how much additional work we need to do here. Obviously, it would help if I had written the right number, so 2, not 8, and we get a value of 7,500,000 joules, or you could simply write 7.5 10 to the power 1, 2, 3, 4, 5 joules. That's the amount of additional work we need to do to push it from 20,000 kilometers to 8,000 kilometers. So just before we finish off this video, I just want to show you another way you can do this. And that's just by using ratios. So we know the formula GM, gravitational potential over R. Now, in the first scenario we had, from 10,000 kilometers to 20,000 kilometers, right, it gave us an amount of that much work being done. Okay, if we look at the next scenario, okay, here we see the distance increase is 4 times as much as what we have here. If we look at this formula here, so if we see an increase by 4, that means 4RGMM, like so, which means the amount of work we did was a quarter. So how to put it? So to go from 10,000 kilometers to 8,000 kilometers, you would have required a quarter of the amount of work in comparison to if it was 10,000 to 20,000 kilometers. So it would have been this value here times by a quarter, which would yield us 2.5 10 to the power of 5 joules. And then all we had to do was do our subtraction at the end, which would have been 1.10 subtracted by that. And so we would have found the exact same response at the end. Okay, because that's the additional energy we needed to do added on to what we already have here. Okay, so I'll just scroll back or zoom back out to the original response for those who would like to see it one last time. So this is how you respond to the 2006 paper. If you found this video useful in explaining how to solve for it, please give it a like, subscribe if you haven't done so already, and I'll see you next time where we go through other physics related components and also exam questions. Take care.